Okay, welcome back everyone. So right now I'm just going to go through a very quick recap of what we learned yesterday. Yesterday we did four different separation techniques. Okay, we learned about the first one, magnetism. Okay, magnetic attraction using magnetism to separate a magnetic material from a non-magnetic material in a mixture. So the advantage of this is it is very quick and simple. If I have a mixture here of sulfur and iron powder, I just need to take the magnet and all the magnetic iron powder is going to get attracted to it and the non-magnetic sulfur will be left behind, right? But the disadvantage of this is you cannot separate between the magnetic materials. So if instead of iron alone, I have iron and steel, this method is not going to work because both will be attracted to the magnet. Similarly, if I have sulfur and another different powder that's not magnetic, let's say copper 2 sulfide, you will not be able to separate them as well because both sulfur and copper 2 sulfide are non-magnetic, neither will be attracted to the magnet. So the next separation technique that we learned about is filtration, which was in the quiz we just did. Okay, how filtration works is we have a filter paper of some sort that has pores, little tiny holes. These pores allow the small particles to pass through and don't allow the big particles to pass through. So then we get a filtrate and a residue. Okay, I'm not spending a lot of time on this because we've already gone through the quiz. You should be able to spell them and you'll be able to identify them by now. So the next method that we learned about after filtration is evaporation to dryness. How this works is we use a Bunsen burner or some sort of heat source and we heat up, okay, a mixture of some kind. This mixture will then have a lot of its liquid evaporate away. So the water in this case will evaporate away, it becomes water vapor, and that leaves a residue of salt that we are unable to evaporate. Salt does not evaporate when heated, it has a very, very high boiling point. So because of that, salt is left behind and we are able to separate a solution from using this method. So the solute escapes, what remains, sorry, the solvent escapes, and what remains is the solute. Finally, we have distillation. What happens if we actually want the solvent more than the solute? Okay, because just now when we have evaporation to dryness, what happened was that the solvent escaped, all of it was gone. Okay, it became water vapor and it went into the atmosphere. We cannot collect it back. But if we actually want the water, let's say over here we have a salt solution again, but this time I want the pure water to come out. I need to use distillation to separate the water from the salt. And this requires us to use, okay, these stoppers to make sure it doesn't escape. And then we pass the water vapor through a condenser, which can then condense the water vapor, turn it back into liquid water, and then we collect it in a conical flask as what we call the distillate. Now, the important thing to remember is that for my condenser, you need to give it cool water for it to do its job. If the condenser does not have cool water, all my vapor will still pass through and then still escape out. Okay, so it's very important. We need to put cool water, cold water even, inside, condense my water vapor, and then it will become liquid and drip out here. So this was a very quick recap of the four separation methods we learned. Today we are going to learn about the last one. Okay, this last separation method is called chromatography. Now, chromatography uses solubility to separate materials. So you can see over here in this video, okay, I have these different dots which are moving up. So how does chromatography work? As you know, if you spill water onto a piece of paper, what's going to happen is that the water will spread. If you've ever accidentally spilled water onto a piece of paper and you've just written on it, what you might notice is that the ink of your pen might also smudge. As the water travels through the paper, the ink actually will smudge. And this is because the ink is a little bit soluble in the water as well. So we use this in a controlled matter, in a controlled manner, in a controlled way to separate substances. So one way to do it is we use many inks and dyes, and we know that different color inks actually are created from a mixture of colored substances. So if you want to separate these substances, we can use this method to do so. So let's take a look at how we work using chromatography. So just like what I said, we have to use a piece of paper and some ink we want to separate, or some substance we want to separate, and we do so by putting that substance at the bottom of the paper and drawing a line. We must know the start line, because if we don't have the start line, we do not know where this substance started from. And if the water carries it, we don't know how far it's carried it along. Then afterwards, we take this paper and we put it into a solvent. Okay, usually we use water or ethanol, which is a different type of solvent, because a lot of things are soluble in water or ethanol. And then over time, okay, the water will travel upwards, and as it travels upwards, it will bring the soluble compounds, okay, the parts of this substance which can dissolve along with it. So you can see over here, okay, how to interpret a chromatogram. A chromatogram is after your chromatography has finished, that piece of paper is called chromatogram. We separate it using the relative solubility. The more soluble something is, the more the water carries it along. So it travels faster and further. Identical items, identical compounds will travel the same distance and produce the same color when you use the same solvent. And then finally, okay, like I said just now, this thing at the end is called a chromatogram. So take some time to copy this down. If you need to pause the video, you can do that. And once you're done, we can move on to the next slide. So the next thing that we need to learn how to do is to interpret a chromatogram. So on the left, we have the setup of chromatography at the start, and then it gives us a chromatogram over here at the end. So you see the importance of having a start line. We know that this green dot here, okay, is actually comprised of a substance that is not soluble. So if it's not soluble, the water is not going to dissolve it. It is not going to carry it along. So it stays here. However, the blue and the yellow substances, they were soluble, they dissolved in the water, and they were carried along as the solvent moved up the chromatography paper. The more soluble something is, as we saw in the previous slide, the more it moves. So what this tells us is this blue substance actually is more soluble in water than the yellow substance. And more importantly, this also tells us that our original substance was actually made of three separate parts, three separate constituents, something here, and something here. We've been able to separate them and identify that there are three constituents of our initial dye. So here's an example of interpreting a chromatogram. Okay, let's say I have four substances which are not supposed to be in food. Okay, A, B, C, and D. Maybe all these things will make people sick if it is consumed. If you eat them, you will fall sick. And then we have some food coloring X, and we want to test, does X contain anything from A, B, C, or D? What we can do is perform chromatography. We put them on the start line and we put four samples, five samples, and then we let the solvent move the compartment, the constituents up. So if X contains any of the four band dyes, it is not safe to be consumed. You cannot eat it, it'll make you fall sick. So after the chromatography, let's say we have this type of a result. We can see that, okay, all of my different food dyes actually have been moved by the solvent. So we can first look at X, and we see that X is made up of three different substances. A is made up of 1, B is made up of 2, C is made up of 2, and D is made up of only 1. So in chromatography, it's really just comparing the different dots that we see, including the color as well. So you can see over here that if I use a pen to draw it out, substance X has a dot here that matches with substance B. Substance X also has a red constituent and a green constituent that matches with substance C. However, substance X does not have anything that matches with A and D. Not going to draw too many arrows to make it very messy, but there is no yellow dot here with A, and there is no purple dot with D. So we know for sure that substance X does not contain A or D. However, we know for 100% certainty that substance X has C inside it. Okay, so it is a mixture of C and something else. But does this mean that substance X contains B since it also has the orange dot? The answer is no, because B also has this blue thing, this blue constituent that X is not showing. So what this means is that substance X does not contain B. It contains something in common with B, but it is not 100% B. Okay, so these can be the conclusions. Identical dyes produce spots at the same height, and sample X, like I said, does not contain A, B, or D, but it does contain C. And since we already know that C is something that cannot be in food, that means that X cannot be in food, it cannot be consumed. Other conclusions we can draw are that substances A and D are pure. So there's only one spot here and one spot here. That means that it did not separate into multiple constituents. There are only one pure substance in A and in D. And for B and C, like I mentioned, since there are two spots, they are made of two different things combined together. Maybe what we could actually do is can test this and find out which one makes it unsuitable to be consumed, or maybe both of them. Okay, so this is also an interesting thing that tells us more about everything that we are testing. We can apply the scientific method to understand which of these might be the thing that makes it dangerous to consume. And then, of course, finally, sample X, there are three different things that make it up. Okay, the two things in C and one of the things inside B. So the application of chromatography is to separate small amounts of substances with different solubilities. This is actually very useful because we can detect pollutants inside water or identify colorings in food products and determine the purity of a substance. Remember just now in the chromatography, the chromatogram, if something is not pure, it is made of two or more substances, we will see that it has two or more spots. So if something only has a single spot, that means that it is 100% pure. However, if you see multiple spots, then it means it's not pure. So we can actually use this to test if something has been tampered with. Let's say I have a sample of medicine. If I use chromatography on it, if the medicine is pure, that means that we should only have one spot at the end. If it's not pure, then we have two or three or more spots. Then that tells us this medicine may not be safe to consume. There are other things inside it outside of what we want. So setting up a chromatography experiment, okay, your sample spot must be small. Why must it be small? Because if it's very big, it might smudge and our results will not be very precise or very accurate. The next thing is the start line must be drawn in pencil. Why can't we use a pen? Because just as we said before, if it is soluble, it will be carried by the water. Pencil lead is not soluble in many solvents. So if we draw it in pencil, it will stay there, it will remain there, and as it remains there, it will be able to tell us where our sample started from. The solvent level must also be below the sample spot, because if we dip the sample into the solvent, it is just going to dissolve entirely into here. Then once it dissolves into here, we no longer have a good chromatography experiment to do. It will just be all over the place and it will end up all over our chromatography paper. Okay, so you can see over here, these are the answers. Okay, if you need to copy them down, you can pause the video based on the explanations here. And then there's another answer about why the sample spot must be above the solvent level as well. So like I explained, okay, it doesn't allow it to dissolve into the rest of the solvent. And if it dissolves in the rest of the solvent, then we won't have any results. So we move on to a summary. That is the end of the 5 separation techniques we have. Okay, just now at the start of this video, I went through the first 4 already. So there's only chromatography left. And what I want you to do right now is take out your workbooks and attempt workbook page 111 and 112. Okay, maybe that would take you about 10 to 15 minutes to do the questions on page 111 and 112. And then after you are done, okay, we move on to the next video where I will go through these answers.